All right, guys, thanks for checking in this video here. We're going to talk about the standard form equation for a parabola. That's what it looks like there, a times x squared plus bx plus c. It's kind of complicated looking at first, but you'll get used to it. We'll see it a whole bunch here in this chapter, all right? So that's the graph of a parabola, all right? And what we're going to talk about a lot in this little video here is this thing called the line of symmetry for a parabola. It's a line that goes right through the middle of the parabola. It's a vertical line that goes right through the middle of the parabola. That point down there is called the vertex, but we'll talk about that more in the other video. But it divides the parabola into perfectly equal halves, all right? And so this standard form equation, what I first asked you guys to do was to have a look at the Desmos activity. So let's go to that right now. That's what you were supposed to do. You're just supposed to kind of play around with the sliders on this thing, all right? There's moving B around, moving C around. I can move them both. I can move A, B, and C. And you can see that each one of them kind of controls a different part of the parabola. When you move the A around, it either points up if A is positive or it points down if A is negative. And the other thing is that when A is a bigger number, the parabola gets steeper and steeper. When A is kind of a small number, close to 0, the parabola starts to open up, and it actually goes completely flat when A equals 0. But then, so that's what A does. It controls the direction that the parabola opens up, and it controls kind of the steepness of the graph. All right. B, on the other hand, moves it left or right, but it's kind of backwards. When I move B to the right, the parabola moves to the left. Or if I move B to the left, that is making B a negative number, the parabola goes into the positive side of the graph. So it's moving it left or right, but it's kind of in the reverse kind of effect. All right, and then C is straight up and down, just a straight vertical change in the thing. Now, I put in here in this one just to show you this equation. There is the equation that you saw right on the very first slide of our little video here. Negative B over 2A, that is the equation of the line of symmetry, okay? So we're going to see that a bunch in this little video here. But here I'm moving I'm moving B left or right, and you can see that line of symmetry is just staying right there in the middle of the parabola, okay? Doesn't matter if I move A, I can move A, and the same kind of thing happens. It's going right through the middle. Moving A is kind of weird, all right? So I won't mess around with that too much. Okay, so that's what we're looking at here, and so there's so what you've seen from that little demonstration, I hope, is that A controls the steepness and the direction of the graph. Okay, check that with what people have said in the discussion forum. You won't find too many that said that exactly, but that's what it really does. All right, and B, on the other hand, controls the line of symmetry. Now that's something that, you know, without knowing anything about the line of symmetry, nobody would have ever guessed that. So that's a pretty hard thing to see from that. But that's what we're looking at here in this video. That's kind of the step up. Here is that line of symmetry that we're talking about. But C, as many of you did notice, controls the y-intercept of the graph, and it's pretty straightforward how it does that. So let's take a look at a couple of examples. All right, and so we'll start off with one, y equals x squared minus 4x plus 5. And there's the graph of that parabola right there. So one of the things you might notice right away is that where's a? Well, a is the number multiplying x squared. And if there isn't a number, then a equals 1. Okay, so that one sort of throws people off at first, but you'll get used to that. If there isn't a number multiplying the x, then the x is being multiplied by positive 1. Okay, B is negative 4 right there, all right, and C is positive 5, and you can see it showing up right there as the y-intercept of the parabola. Okay, so C is easy to take care of. It's easy to see the connection between the number and the point on the graph. B is a little bit trickier. By the way, A is normal there. That's kind of what we'll see a lot of that in these videos, so I don't know, not too much to say about that, I guess. Okay, now let's talk about this line of symmetry thing, because it's a bit of work. Negative B over 2 times A means I have to take the numbers for A and B and put them into that formula. Okay, the formula itself has a negative sign in it, so I don't want to lose that. So I'm replacing B with negative 4. So that means I've got negative 4 over 2 times 1. 2 times 1 is just 2, and those two negatives sort of cancel each other out, which means I've just got 4 on the top and 2 on the bottom, and that equals 2. And you can see that the line of symmetry for that parabola, if you were going to draw the line right through the middle of the parabola, it's right there at x equals 2. All right, so that checks out. That's good. That's kind of what we want to see, is that how that formula takes the numbers from the parabola and it shows up right there on the graph. Let's take a look at another one. This time I've got y equals x squared plus 5x plus 1. Once again, a is positive 1, and this time c is also positive 1, so you can see that right there as the y-intercept of the graph. And the line of symmetry, all right, that negative b over 2a little formula is going to use positive 5 and positive 1. So when you put those in there, positive 5 over over 2 times positive 1, is 5 over 2, but there's that negative sign from the formula. So actually it ends up giving us negative 5 halves, or negative 2.5. And right there you can see that that's where the line of symmetry is for that parabola. The parabola has been moved over to the left because b is a positive number. It's weird. It's kind of backwards. All right? But when you think about it in terms of that formula, the formula has a negative sign. It kind of makes sense after a while. All right, so that's how that one ends up. So that x equals negative 2.5, that's the equation of the line of symmetry. It's a vertical line, and if you remember back from Math 1, the equation of a vertical line is always x equals a number. So there it is. There it uses a and b, and that's how you get that's how you get the value of the line of symmetry, or the equation of the line of symmetry for a parabola is a and b. All right, let's do one final example here, and this time a is going to be a negative 1. B is also negative, and now c is positive 3. Once again, there's our y-intercept. No big deal. C is positive 3. The y-intercept is positive 3. And since the parabola is upside down, you can see a is negative 1 now. It's a negative number, so that's why the parabola is opening upside down. People say that it opens downwards. That's a good way to say it. You could say it's upside down, and probably everybody would know what you mean, though. Okay? Now, line of symmetry, all right? Negative b over 2a, and this is going to be tricky, folks, so just keep in mind here, it looks like the parabola has a line of symmetry at x equals negative 2. All right, that's what it looks like the parabola goes through. And I just want to double check that with the formula with you, because this is going to be tricky. I put this example in here because all these negative signs it makes it kind of tricky to deal with sometimes, okay? So negative b over 2a, and I replace b with negative 4 and a with negative 1. So there's 3 negative signs in there, right? Let's keep straight that there is one negative sign that is from the formula itself, and then the other 2 negative signs are from the numbers in the equation, all right? Don't leave any of them out. Don't add ones that aren't there. And so you just have to be precise and careful. Go slow until it feels comfortable and easy, and you're being accurate all the time. When you do all of that stuff, all right, I would recommend just kind of leaving that negative sign from the formula there for a second. Deal with the other numbers. Negative 4 over negative 1 is positive over positive, okay? So it's 4 over 2 times 1, 4 over 2. But that negative sign from the formula is still there, and that's what makes it equal negative 2. And yes, that checks out. There's our line of symmetry at exactly x equals negative 2. All right, folks, that was a lot of talk about this thing, but I hope it was helpful. This standard form equation is going to be a big deal for Chapter 5. Bigger than the vertex form, but I'm going to show you, we'll have another little video about the vertex form, all right, pretty soon here. All right, thanks for watching.